Okay, here we want to solve each system using elimination. And for our first equation, I'm just going to write equation 1 here. We have 2x minus 4y equals negative 14. And for our second equation, we have negative 2x plus 7y equals 29. Okay, so what we want to do here, this is very straightforward. We want to add this side and this side together, okay? Now what's going to happen is because 2x and negative 2x are opposites, that variable is going to drop out. Okay, so 2x plus negative 2x would be 0, and then negative 4y plus 7y would be 3y. So this would be 0 plus 3y when you add these two sides together, and this will be equal to this side plus this side. Okay, negative 14 plus 29 would be 15. Okay, so our x variable has been eliminated, and now we can just solve for y. Right, you'd have 3y equals 15. You divide both sides of the equation by 3, and we'll get y equals 5. Okay, so we have our y value now, and to find our x value, we simply plug in our y value back in for y in one of the equations, right? So we could do 2x minus 4 times, we're going to plug in a 5 for y, equals negative 14. Okay, so this would be 2x minus 20 equals negative 14. Add 20 to both sides of the equation. We get 2x equals 6. Divide both sides of the equation by 2, and we're going to get x equals 3. Okay. Now we want to check to make sure that we have a correct solution. Right? The solution to this system would be the ordered pair 3, 5. All right, so to check this, what we want to do is go back to each equation and plug in a 3 for the x and a 5 for the y. We're going to make sure it's a true statement. So for our first equation, we had 2x minus 4y equals negative 14. So 2x, so 2 times 3, minus 4y, so 4 times 5, should be equal to negative 14. Now let's see if this is true. 2 times 3 is 6. 4 times 5 is 20. And you can see that that's going to be true. Right? Let me just fix that real quick. All right, 6 minus 20 is in fact negative 14. So you get negative 14 equals negative 14. That's a true statement. All right, our second equation was negative 2x plus 7y equals 29. So that would be negative 2 times x, which we plug in a 3 for, plus 7 times y, which we're going to plug in a 5 for, should be equal to 29. Okay, negative 2 times 3 would be negative 6. 7 times 5 is 35. And this should equal 29. And it does, right? Negative 6 plus 35 does equal 29. So you get 29 equals 29. That's a true statement. Okay, so our solution, which is x equals 3 and y equals 5, is correct.
In this section, we're going to be factoring trinomials. Based on what you've learned so far about factoring, the first thing you're going to probably try to do here is factor out a greatest common factor. The problem is, there is no factor that is in common to these three terms. So you might think that this problem is unfactorable. However, the trinomial that you see is in a special form that can be factored in a new way. The first term has an x squared. The second term has an x, and the third term is a constant term. When a trinomial is in this form, it can be factored as the product of two binomials. In other words, we're going to set up two sets of parentheses, and within each set of parentheses will be the two terms that compose each binomial. So what goes inside these parentheses? Well, the first term in each binomial will be a factor of the x squared. Since x squared factors as x times x, we use x as the first term in each binomial. The second term in each binomial will be a factor of your constant term, or your 10. The problem is 10 factors in different ways. 10 can be thought of as 10 times 1, or it can also be thought of as 5 times 2. So how do we know whether to use a 10 and a 1 or a 5 and a 2? Well, take a look at your middle term in your original polynomial. The rule is the factors of the last term that you will use have to add to the middle term in the original trinomial. So which pair of factors adds to 7? Well, 5 and 2. So we're going to put a 5 in our first binomial and a 2 in our second. And there's your answer, which is a factored version of x squared plus 7x plus 10.